For this example, we're going to solve by factoring, but we're going to look at something a little more complicated. As we look at this equation, we notice we have a binomial within a bracket that is kind of acting as a factor in the first two terms, but not the third term. It almost looks like the kind of trinomial we're used to factoring, but normally we would just have a single variable there, not a binomial. The easier way to deal with this is to use what's called the substitution method. In the substitution method, we're going to take that complicated 2x plus 1 and replace it with something simpler. So let's pick a letter like A, and let's say that we will let A equal 2x plus 1. This allows me to rewrite my equation in a way that it's going to look a bit simpler. So instead of 2x plus 1 squared, that would just be A squared. Minus 19, again, times A instead of the 2x plus 1. Then plus 90 equals 0. This gives us a much simpler equation for factoring purposes. We just need to find a pair of numbers that will multiply to 90, add to negative 19. Those numbers will be negative 9 and negative 10. At this point, we can go directly into our factored form. A minus 9 times A minus 10 equals 0. At this point, if we were solving for A, we could just take each factor separately. Either A minus 9 is equal to 0, in which case A is equal to 9, or A minus 10 is equal to 0, in which case A is equal to 10. Now with this method, there is one extra step to keep in mind, and that is we were actually trying to solve for x, not A. So we need to do one extra step. If we know that A is equal to 9, but A is also 2x plus 1, we can set 2x plus 1 equals 9. 2x plus 1 equals 9. Similarly, for our other case, 2x plus 1 equals 10. And then we solve for x in each case. In our first case, 2x is equal to 8, and x is equal to 4. In our second case, 2x is equal to 9, x is equal to 9 over 2, and we prefer a fraction, so we'll just leave it as an improper fraction. This is sort of the faster way of solving. The other way to solve this by factoring, if we come all the way back to our initial equation, we can expand it out, we could combine the like terms, and we could try to solve by factoring that way. It does take some more steps, but let's try it now just so we can compare and see that we do get to the same solution. So I'm going to come a little bit down, and I'm going to copy out our equation again. So we have 2x plus 1 squared minus 19 times 2x plus 1 plus 90 equals 0. And I'm going to start by just expanding each bracket. Our first bracket gives us 4x squared plus 4x plus 1 minus 38x and minus 19. If we do the minus 19 times our binomial, and then plus 90 equals 0. So already it starts to look a little more complicated. We can combine the like terms. So 4x squared, combining our x terms, we get minus 34x and plus 72 equals 0. These numbers are a bit big to work with. The first thing I would do is look for any kind of common factor. For example, all of our coefficients and our constant are a multiple of 2. So let's just factor out the 2. We get 2x squared minus 17x plus 36 equals 0. And at this point, we do have a trinomial we can factor. Because we have that a value that is greater than 1, we're going to go to the box method for this. So I'm going to look for two numbers that multiply to 72, but add to negative 17, that will be negative 8 and negative 9. and set up our box. We have a 2x squared. We have a 36. We have a minus 8x and a minus 9x instead of the minus 17x. Okay, starting with our rows and finding our greatest common factor. The first one is 2x minus 9. For the first column, it's just going to be x and then minus 4. We have a negative sign in front of the first term, so I make it negative. Our factored form of this equation is now 2 times 2x minus 9 times x minus 4 equals 0. At this point, if you wanted to divide out the 2, you could, but it's also not really doing any harm there. It does not give us a solution because there's no way that 2 will be equal to 0. So our cases are either 2x minus 9 equals 0 or x minus 4 equals 0. That gives us solutions of x equals 4 and x equals 9 over 2. Comparing those to our earlier solutions, we had the same two solutions for our first method, but our first method had much easier factoring. Our second method requires more steps of multiplying out and a slightly more complicated factoring, but we end up solving for x directly. Usually the first method of substitution is our preferred method, but if you run into a case where you can't use substitution, that's when you can use the second method, expand everything, and then factor.